Bless you. All right, so today we're going to look at conditions for special parallelograms. This is just turning around what we have done so far with the rectangles, rhombuses, and squares. So in other words, if you have a figure, how do you know that it's a rectangle? How do you know that it's a rhombus? How could you know that it's a square? So here are the conditions for rectangles. Any of these three will be enough for you to know that the figure you have is a rectangle. The first one is the definition, a quadrilateral with 4 right angles. That's got to be a rectangle. That's the definition of a rectangle. If you know that it's a parallelogram to begin with, then all you need to know is that it has 1 right angle. Now let's think about that for just a second. Like, well, if it only had 1 right angle, how do I know that that's going to be a rectangle then? Well, if we know that this is a parallelogram to begin with, you don't need to draw this, and this is a right angle, then what has to be true about this angle if it's a parallelogram?
It has to be right.
It has to be a right angle because
Because the opposite sides are not that, like not the sides, the opposite.
very good. The opposite angles have to be congruent. Okay? What about this angle right here?
It would have to be 90.
Why?
Because those two are 90. And seems like interior.
Wait. I heard several things at once and I couldn't decipher. Yes. Yes. Since either way you want to go, we've got parallel sides, and then same side interior angles have to be supplementary. And then if this is a parallelogram, we can do the same thing again, or we can say that the opposite angles have to be congruent. So if you know it's a parallelogram to start with, you only need to know 1 right angle. And then the last one is a parallelogram with congruent diagonals, then it's going to be a rectangle. This is something that everybody who builds things knows this rule. Whether it's a house or a picture frame or anything like that, they know this rule. What you do when you're actually building a wall is you've got a bottom plate, which is a long 2x4, a top plate, which is exactly the same length, and then you've got all these studs that run between them that are all exactly the same length. You know it's a parallelogram because both pair of opposite sides are parallel and congruent. What you don't know is whether it's a rectangle or not, and you don't get out a little bitty protractor and measure the angle. What you actually do is you get a long tape measure and you measure from this corner to this corner and that corner to that corner. If those are the same length, it's a rectangle and you're ready to put the wall up. If they're not, you literally get out a big hammer and wail on one corner until it goes into square. And then typically you'll put a diagonal brace so that it stays square. Okay, if you don't, what happens is if you have a parallelogram, I mean, just think about that for a second. If your wall, I mean, this is way over emphasized, but if your wall was like this, what's going to happen when you start putting weight up here on the roof? Yeah, it's just going to fall down. Okay, and I've actually seen a house where they didn't put in the diagonal bracing right, and the whole house just kind of, when they started they didn't have all the roof on, but the whole thing just kind of twisted all the way around and fell most of the way down. They had to start over. Okay, that's not good. So you want to check from corner to corner to see if it's a rectangle or not. Okay? All right. So then how do you know it's a rhombus? Well, there are 4 different ways you can know that it's a rhombus. First, know that it's a quadrilateral with 4 congruent sides. And this is very faint on your picture, but this is the definition. Might want to add, yeah, you can see it, but just barely, barely. That's the definition. Okay? If it's a parallelogram, there are 3 different ways you can know it. One is to know that the diagonals are perpendicular, because that's not true in an ordinary rectangle. Second, and this one doesn't get used nearly as often, but if the diagonals bisect the angles, then it's got to be a rhombus. And last, if you just have 2 consecutive sides congruent, and you know that it's a parallelogram, it's going to be a rhombus, because if it's a parallelogram, we know the opposite sides are congruent, so all 4 sides are going to be congruent. And then the last question is, well, how do you know whether it's a square or not? Well, you show that it's both a rectangle and a rhombus. If it's both a rectangle and a rhombus, then it is a square. Okay, and down here at the bottom, we're going to do something real quick. We're going to draw a big Venn diagram. So, our big circle is going to be all the parallelograms. And yes, you are putting this on your paper. You ever look at a word and suddenly go, how do you spell that? Is parallelograms 2 R's? No. So if this is all the parallelograms, then inside this there are 2 special groups that overlap one another. Pardon?
No, not yet.
The rectangles and the rhombuses. And then here where they overlap, this is squares. In order to be a square, it has to be both a rectangle and a rhombus. Okay, any questions about that? All right, well, let's look at some different problems that you may be asked to do. All right, so this is the one I was talking to you about just a couple of minutes ago. A wood frame wall is built for a house. Here's the diagram below. So that XY and segment WZ are congruent, and segment XW is congruent to segment YZ. Once the wall is assembled, XW and YZ are measured and found to be congruent. Why must this frame be a rectangle? Well, what do we know first? This first part where it tells us these 2 sides are congruent, XY and WZ, and XW is congruent to YZ. What does that tell you about this? When both pair of opposite sides of a quadrilateral are congruent, it's got to be a parallelogram. So, since both pair of opposite sides are congruent, WXYZ is a parallelogram. In most cases, that's going to be the first thing you're going to do is prove that it's a parallelogram. Only very rarely will you not do that first. And then what are segments XW and YZ? I'm sorry, that should be, oh, I apologize. Let's change this. This is not what that should be. That should be XZ and YW. Please, everyone, change that on yours. XZ and YW. Cole, you got that? So, what are these segments? What is segment XZ? A diagonal. And YW, the other diagonal. Since the diagonals are also congruent, WXYZ must be a rectangle. You're just going to write a short explanation. It's a couple of short sentences. Okay, any questions about that? All right, let's go on to the next example then. For each of these, it says, determine if the conclusion is valid. If not, tell what additional information is needed. Okay, so let's take a look at this first one. We know that segment AB is congruent to segment CD. And I'm going to mark it. You might want to mark it lightly on yours so that you can erase it for the next one. AB is congruent to CD. And BC is congruent to AD. Before we go on any further, what do we know about this figure already? We don't know it's a square.
It's a right angle.
All sides are equal.
No, we do not know all sides are equal. It doesn't say that.
But it's a right angle.
Both pair of opposite sides are congruent.
So since both pair of opposite sides are congruent, what do we know about this?
Parallel.
It's a parallelogram. So far, all we know for sure is that it is a parallelogram. Then it says AD is perpendicular to DC. That's a right angle. Well, if it's a parallelogram, we talked about this a minute ago, and this angle's a right angle, what else do I know?
ABC is a right angle.
ABC is a right angle, and because of the same side interior angles, this whole angle at C and this whole angle at A, angle DAB, is a right angle. What do I know so far at this point?
It's a rectangle.
It's got to be a rectangle. It's a parallelogram that's got right angles. It's got to be a rectangle. And then AC is perpendicular to BD. That means these are right angles. What has right angles in the middle?
Rhombus.
A rhombus. So now we know it's a parallelogram that is a rectangle and a rhombus. So is it a square? Yes. So all we have to write for this is that this is valid. We have everything we need.
Is it not a square?
Pardon?
Is it not a square?
No, it is a square. So I'm saying that this is a valid conclusion.
Oh, so you were trying to confirm.
Yes, or if it's not valid, tell what we need to know in addition. Okay? All right. I'm going to erase those marks. Let's look at this one. Here I know that AB is congruent to BC. And AC is perpendicular to BD. And their conclusion is that this is a rhombus. Do we know for sure that this is a rhombus?
No.
No. Do we even know that it's a parallelogram?
No.
No. If we knew that it was a parallelogram and it had perpendicular diagonals, does that mean it has to be a rhombus? Yeah, that's one of the properties of a rhombus. So this is invalid. We need to know that ABCD is a parallelogram. We don't know that yet. All right, let's take a look at this last one. So we know that AB is parallel to CD. Do we know it's a parallelogram yet? Not yet. Let's go on to the next part. AB is congruent to CD. Do we know it's a parallelogram now? Yes, I've got two sides that are both parallel and congruent. And then it says AC is congruent to BD. So here we knew it was a parallelogram. Now we've got congruent diagonals. Does that make it a rectangle? Yes, this is valid. So always first look to see, do I even know for sure that this is a parallelogram? If not, the answer is that it's not valid. Then look for the extra stuff. All right, page 3. So here it says, use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or square. Give all the names that apply. As always with graph problems like these, a graph is nice, but it's no proof of anything. You got to do more than that. So let's see. A is at 0, 2. B is at 3, 6. C is at 8, 6. And D is at 5, 2. All right, if you had to guess just based on the drawing, what would you guess? Looks like it's a rhombus. So let's start and show that it is a rhombus, and then we'll show that it's not a rectangle. And it says use the diagonals. The diagonals are AC and BD, so I need to be talking about AC and BD the entire problem. So, to determine whether it's a rhombus or not, a rhombus has perpendicular diagonals. So let's find the slopes of these two. So the slope of segment AC, if I count that, that's 1, 2, 3, 4, and then over 1, 2, 3, 4, 5, 6, 7, 8. So that was 4 over 8, which is 1/2. And then the slope of BD is, see, that's down 4 over 2, so that's negative 4 over 2 is negative 2 over 1. So what do I know about those two? They're perpendicular. So AC is perpendicular to BD. And if the diagonals are perpendicular, what do I know so far about this? It's got to be a rhombus. It's pretty obviously not a rectangle, but I still need to show that. Well, to show that, I need to show that the diagonals are not the same length. And you can't just go, well, they don't look like it. You got to actually find the lengths. The nice thing about it is, though, is that we're just going to do the Pythagorean theorem. And when you counted the slope, you actually, if you drew in the slope triangle, like this, for AC, where this was 4 and this was 8, this is your hypotenuse. So 4 squared plus 8 squared is equal to AC squared. So that's 16 plus 64 is AC squared. So AC is the square root of 80. And the nice thing about these, you're not required to simplify it, because all we want to know is, are they the same or not? Okay? So now let's find the length of the other diagonal. Drawing my little slope triangle here. I've already counted that. That's 4 and 2. So that's going to be 4 squared plus 2 squared. Gives me the length of BD squared. That's 16 plus 4 is BD squared. So the length of BD is the square root of 20. Lose the game? Okay, let's not, okay? So the length of AC is not equal to the length of BD, which means it's not a rectangle. So the only name that fits this one is a rhombus. This is the work that I expect to see on these problems. Find the slopes, make sure you're labeling them. If the slopes of the diagonals are opposite reciprocals, then those are perpendicular and I know I have a rhombus. If not, we know we don't have a rhombus. Find the lengths of the diagonals. If they're the same, we know that we have a rectangle, because it told us it was a parallelogram already. Okay? All right, let's do the second one. See, E is negative 4, negative 1. F is negative 3, 2. G is 3, 0. And H is 2, negative 3. So again, this says use the diagonals, so I've got to find out information about FH and EG. Let's show, unlike the last one, that this is not a rhombus. So I find the slope of FH and the slope of EG. The slope of FH, see that's down 1, 2, 3, 4, 5, and to the right, 1, 2, 3, 4, 5. It's negative 5 over 5, which is negative 1. And the slope of EG, see that it's up 1 and to the right, 1, 2, 3, 4, 5, 6, 7. So what does that tell us about those two segments? Are they a rhombus? Are these perpendicular? So FH and EG are not perpendicular. So this is not a rhombus. And again, we don't have to recount these numbers. We can just use these two numbers from before we simplified to find the length of FH. It's going to be 5 squared plus 5 squared is equal to FH squared. If you want to count it, you're welcome to, but it's always going to work out that way. So 25 plus 25 is equal to FH squared. So FH is the square root of 50. Then for EG, it's going to be 1 and 7, so 1 squared plus 7 squared is EG squared. So it'll be 1 plus 49 is EG squared. EG is also the square root of 50. So what does that tell you about those two segments? They're congruent to each other. They have the same length. If we have a parallelogram with congruent diagonals, what kind of a thing is it? A rectangle. So on this one, the only correct name is rectangle. Remember, if it's both a rhombus and a rectangle, then what is it?
Square.
It's a square. All right, any questions about that? All right, your assignment is in the book.